Chapter 2 is talking about functions and their graphs. So here we're going to introduce to you how to graph a function on a two-dimensional plane, which is also called the Cartesian coordinates. So before we do anything, we have to introduce to you the Cartesian coordinate system. The Cartesian coordinate system. Let's just draw it on this here. Cartesian coordinate system is a two-dimensional plane. You have x, you have y. You have x-axis and you have y-axis. The intersection of the two is 0. Okay, they intersect at the x value of 0 and the y value of 0. So if you will, is 0 and 0. X value is written first, x, y. X value is written first, so 0 and 0. To the right on the x line, you go toward infinity. To the left from 0, you go to minus infinity. On the y-axis, to the top you go to infinity. To go to minus infinity, that would be in the bottom of the x-axis, the horizontal axis. So this will go to minus infinity, right? So any point, and then you have to choose the scale, by the way. You choose 1, 2, 3, 4, and so on and so forth. To the left, the same distance, which is from here to here, that define your 1 unit, that has to be constant distance. So again here, the same distance will take you to minus 1, minus 2, minus 3, minus 4, and so on and so forth. On the vertical axis, you have to choose the same scale also. It doesn't have to be the same scale as x-axis, but it has to be the same on the y-axis. Okay? So if I choose, for example, this distance from 0 to this as 10 unit, then additional this much would be additional 10. That would take you to 20. Additional that would take you to 30. And on the minus on the lower part, it would be a minus 10 and a minus 20. So it has to be consistent on each axis, right? These distances are the same. Any point on the plane, any point on this surface, on the flat surface, on a two-dimensional surface, would have two coordinates. One is an x value, the other one is y value. So for example, if the problem says identify on the Cartesian coordinates the value of 2 and 10, that means x is 2 and y is 10, then you say here is x of 2, here is y of 10. From x of 2 I come up, y of 10 I come up. This point here is identified as point with the coordinates of 2 and 10. Or if I ask you to find 5 and minus 15, for example, that means x value is 5 and y value is minus 15. X of 5 would be here. Minus 15 would be between 10 and 20. So this point here is a point with the coordinates of 5 and 15. So it's very important to understand the Cartesian coordinates or two-dimensional plane, because you're going to use this to graph your functions. Let's get rid of these. and see what other topics we will cover in chapter 2 before we start the chapter. So in this first slide, it will tell you the topics. I keep reminding you that additional exercises from the end of the chapter and also review exercises is on a separate video. Here we just have the lecture videos on the topics inside each section. So the Cartesian coordinate system, we just explained it, and we're going to explain it further in just a moment. Then we talked about equations of lines, right? Linear equations, as you will. We talked about functions and their graphs. What is a function and here how you graph it. We talked about algebra of functions, how to add, subtract, multiply two functions. We talked about linear equations versus quadratic equations, right? How to graph linear equation and how to graph quadratic equations. And finally, we talked about mathematical models. And we will have examples of that at the end of the chapter. We will do one of the examples here. Start with section 1.1 in your book. Sections 1.1, Cartesian coordinate system. Again, Cartesian coordinate system is where you have the x-axis or the horizontal axis and the y-axis, which is the vertical axis, right? And any point on the plane, any point on this sheet would be identified with two coordinates. One is x and one is y. The x and y coordinate, x has a value and y has a value. As for example, it says plot coordinates a point with the coordinates of 4 and 2. That means x value is 4 and the y value is 2. X of 4 is here, y of 2 is here, so you come out. So the point should be somewhere about here, right? That's 4 and 2. It says plot a point with the coordinates of -2 and 1. That means x is -2, so you go to the left of the y-axis. This is the -2 here. Identify, this is a -2. And 1, this is a 1. So you come out, and this would be the point. Well, have a news for you. This is not correct. What I have here is correct. This is -2 and 1. What they have here is -2 and -1 because we are on the lower part. This is a -1. So that's what they did. They did a -1, not a +1. And finally, a 2 and a -3. X of 2 and y of -3. 2 here, -3 here, you come out. This would be the point with coordinates of 2 and -3. Okay, so again, pay attention to the mistake they had in plotting that. The Cartesian coordinates with the x-axis and the y-axis is divided into 4 quadrants. The 4 quadrants. Quadrant number one, which is this area, would have both x value and a y value as positive. Quadrant number 2, which is this area, would have x value negative and a y value, however, positive. quadrant 3 would have both x and y negative value. Both of them would be negative, and quadrant 4 would have x as positive and y as negative. So when you see x are positive, y are positive, y negative, whatever, you would know exactly which quadrant you should go to. Now a straight line. In a straight line, we talk about the slope of a line. The steepness of the line, is it going up very steeply or rather flat? And how to find a line using point slope form or slope and intercept form, and also a general form for a straight line. First thing, slope of a line. Slope of a line. How do you find the slope of a line? The slope of a line, the slope of a non-vertical, here it says the slope of a non-vertical line that passes through the points with the coordinates of x1 and y1 and x2 and y2 is given by this, right? Is given this by this equation. So if you have, let's say something in the first quadrant, I'm just going to draw the first quadrant. So you have 2 points, one point with some coordinate and another one with another coordinate, right? What we are interested in is the slope of the line that connects these 2 points together. The way you find the slope of the line, see, this first line has a coordinate of, say, y1 and x1, whatever those values are, right? This is the first point, call it point A, with the coordinates of x1 and y1. And another point, point B, with the coordinates of x2, with the coordinates of y2, x2, y2. So the slope of this line, is rise over run. The rise, in this case fall, between A and B is this distance from here to here, which is change in y. And the run is measured horizontally as from here to here, which is change in x. So the distance from here to here, which is the same as from here to here, this distance divided by this distance. That is shown as change in y, that is shown as change in x. By the way, this is a 2 here. So change in y is y2 minus y1, and change in x is x2 minus x1, right? This is how you find the slope of a line. If you have the coordinates of 2 points, you should be able to find the slope easy. So for example, it says find the slope of the line that passes through the point with the coordinates of 4 and 0. That means x1 is 4, y1 is 0, and 6 and minus 3. That is h2 and y2. So all I have to do is to plug it into this equation, right? And just do it right up here. So this would be equal to y2, that's the second y. This is the first point. This is the coordinates of the first point. This is the coordinates of the second point. So y2 in this case would be minus 3, minus y1, minus 0, divided by h2, that is 6, minus x1, that is 4. So that would be equal to minus 3 minus 0 is minus 3. And 6 minus 4 is 2. So the slope here is the slope of a line that goes through those 2 points is minus 3/2. By the way, the negative slope means the line is going downward from left to right. A positive slope means the line is going upward from left to right, right? So this line here, for example, has a positive slope, right, which is going upward, and this line here would have a negative slope. This is negative, this is positive. Okay. So find the slope of the line that passes through these points. It would be minus 3/2. Changing y over changing x, minus 3 minus 0, 6 minus 4, minus 3/2 or minus 3/2. That's the same thing we found here. Defining what parallel lines are. Two lines would be parallel if their slope is the same. Two lines would be parallel if and only if their slopes are equal or both are undefined. Okay? So two lines can be straight vertical or horizontal, also completely horizontal, and that can be parallel too, right? Two lines are perpendicular if and only if the product of their slopes is -1. That is, one slope has the opposite sign and is the reciprocal of the other slope. So if one of them has the slope of 3/4, the other one would have the slope of -4/3. Okay? The sign would change from positive here to negative, and also would be reciprocal. So we have two lines where the slope of one is 3/4, the other one -4/3. That means these two lines, when you graph it, they're going to be perpendicular to each other. Okay, we're going to use this to find equation for a line. Here is finding the equation of a line that passes through the point with x1 and y1 coordinate, and it has a slope of m. That is the formula. So it shows that if you know the slope and you know the coordinates of one point, that is x1 and y1, you can come up with the equation of a line. You can come up with the equation of a line. Okay? Equation of a line. Find an equation of a line that passes through the point 3 and 1 and has a slope of m equal 4. So all we have to do is to plug in for m in this, you plug in 4. For x1, you're going to plug in 3. For y1, we're going to plug in 1. And that way we'll get the equation of a line. So you see, y minus y1 m times x minus x1, which is what we have up here. Then for y, they plugged in 1. For x1, they plug in 3. And for the slope, they plug in 4. That's what we have here. So when you do that, you multiply 4 by x minus 3 would be 4x minus 12. Take the 1 to the other side. Or actually they took everything to one side. Another form of this you can write is take the 1 to the other side. So that means y would be equal to 4x minus 11. That's another form. We're going to see the different form of equation of a line you can write. Both of these are correct. This is just two forms of writing it. This is one form using the slope-intercept form. Slope-intercept form. This is the y-intercept. Intercept, and this is the slope. Okay, and again, y-intercept is where the line, here is x, here is y, where the line intercepts the line intercept the y-axis. So that is B. So equation of a line with the slope m and the intercept at 0 and b, 0 means x is 0, right? So that's basically this point. This point has coordinates of 0 and b. Find an equation of the line that passes through the point of 0 and minus 4. So 0 and minus 4, that's in this format. So that means b is how much? B is minus 4. And it has a slope of 4/5. Well, easy. So you plug in y equal m is minus 4 minus 4x. I'm sorry. M is not minus 4. M is 4/5. So it would be 4/5 x minus b would become minus 4. So that's the equation of a line in the form of intercept, which is minus 4, and the slope, which is 4/5. Okay. So very easy. Just plug in numbers. Determine the slope and y-intercept of this line. Well, in order to find the slope and the y-intercept, you have to put it in this form. Y equal mx plus b. It has to be in this format to clearly see the slope and the y-intercept. No matter how it is, you have to keep. In other words, you have to keep y, only one y, with no coefficient, to the left-hand side, everything else to the right-hand side. And when you do that, the coefficient of x would be the slope, and the constant would be your y-intercept. Now here, we have 2y equal 3x plus 1. So clearly, it's not y, it is 2y. So you have to make that into y. So what do? You divide both sides by 2. So you divide both sides by 2. So it would be 2y divided by 2 equal 3x divided by 2 plus 1 divided by 2. So 2 and 2 would cancel. Now you have y equal, here 3x divided by 2, I can write it as 3/2 x plus 1/2. Now it's clearly in this format. So when it is in that format, I can see the coefficient of x as the slope. So m is equal to 3/2. And the constant is my y-intercept. Okay, so it's very easy. All you need to remember is to put it in this format, y equal mx plus b. Okay, let me clean this up and see if they did exactly the same way I did this to come up with the slope of 3/2 and the intercept of 1/2. There you go. Y, divide everything by 2, y equal 3/2 x plus 1/2. So the slope is 3/2 and y-intercept is 1/2. So it's exactly the same thing we had. So no problem there. The general form of a linear equation or equation of a line is when you have everything on the left-hand side, on the right-hand side you will have 0. So this is another form. So we had three different forms of the equation. So ax plus by plus c. A, b, and c are real numbers. They are constant. A, b, and c are constant, and a and both cannot be both 0. One of them can be 0. If both of them are 0, that means c is equal to 0, right? So both of them cannot be 0. And we note here at the bottom, an equation of a straight line is a linear equation, and every linear equation represents a straight line. This is a linear equation. The powers are 1. There is no second power, third power, right? The exponent is 1. So straight line is represented by a linear equation, and a linear equation would give you a straight line. That's what this note is talking about. Some special cases of line is if you have a vertical line, such as this one, which is crossing the x-axis at 3, right? The x-axis at 3. The equation of this line is that it is x equal 3. So that means no matter what the value of y is, y can be up here, 1, 2, 3, 4, whatever, or negative. No matter what the value of y is, x remains at 3. So x is equal to a constant. So when you have x equal to a constant, in order to graph it, you know it would be vertical line crossing the x-axis at that a, whatever a is, positive or negative. In this case, a is 3. X equal to 3. That's the equation of this line. Okay? A horizontal line says no matter what the value of x is, the value of y remain constant. So in this case, let's say this is 2. So this is at 2. So this one shows y is equal to 2. Or y is equal to the intercept, b. This is the y-intercept. Y is equal to 2. That means no matter what the value of x is, positive, negative, 0, that y remains at 2. If that is the case, you get a horizontal line on the Cartesian coordinates. Now here is a problem, an example. It says find an equation of the line that passes through the point -2 and 3 and is parallel to the y-axis. It's parallel to the y-axis and it passes through -2, x coordinate is -2 and y is 3. So -2 and 3, here is -2. Here is 3, So you come up, come here. It has to pass through this point, right? And it would be parallel to the y-axis. So it passes through this point and is parallel to the y-axis. So it's going to be a line like this. What is the equation of this line, which is vertical? Well, that means h is equal to, no matter what, the y value, h would be equal to minus 2. That's the equation of a line that passes through this point minus 2 and 3 and is parallel to the y-axis. Okay. They have a much straighter line than I did. So it's a vertical line. H minus 2. There it is. Got the same thing.